off yesterday, 3-6, this on the front side, this part A here, we pretty much finished it. As the bell was ringing, I was writing the factored form. Now, we had found, using Desmos, zeros of -1 and 2/3, right? Okay, those were zeros we had found. So those are where those two come from. Then we had found this was the remains after we used synthetic division. When I say 3x squared plus 3x plus 3, that was what we had after synthetic division. From there, we used quadratic formula, right? Now, officially, we used quadratic formula just on x squared plus x plus 1. Notice there was a GCF that we divided out at the time, right? One thing I want to make sure I mention. If there's an a value of 3, it often kind of gets divided out in the problem. That's what this is right here, is the a value, and you will have to have that, okay? So that's one of those things. Beware that if there's an a value on your problem in the original problem, so a number in front of basically your leading coefficient, that will have to be out front, okay? So in this, really like this problem, there's two big sticklers in homework, okay? I think it's going to end up being numbers 6 and 9 are going to be the difficult ones, I think. I did have 3, but I took 1 out. Are there only 9 problems in homework now? Okay, because I did have 3, and I took 1 of them out. But there's still 2 that are going to be toughies. So, okay. Okay, let's try B. Try and move through it because I also want to get to the back, okay? So this kind of reviews what we were doing with A yesterday. The directions were find all complex roots and write it in factored form. Okay? So, what did we start off doing first? Yeah, our step 1 was PRRs. How did we find PRRs? Okay. Yeah, we're doing P over Q, and it's factors of -10 over factors of 1. Does that sound familiar? Yeah. Factors of the constant over factors of the lead coefficient. I like this lead coefficient.
Very easy.
It's a 1. I like that, right? I'm like you guys. I'll take the easy when I can get it. So factors of -10. What are my factors of 10? Okay. I agree. Think in those pairs, 2 and 5, 1 and 10. So 1, 2, 5, 10, all of the plus or minus variety. What are factors of 1?
1.
Plus or minus 1. Okay. If we make our official list, everything over 1 means my PRRs are just plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Yes? What were we doing with those PRs?
Checking the graph on Desmos.
Yeah, we were checking the graph on Desmos to see which ones work. Okay, so this is what I called step 2. That was to check the graph on Desmos, and that will tell us from this list what we should try. So what are you doing on Desmos? You are graphing it, yes?
Mm-hmm.
I'll see if my Desmos comes up easily or not. Not really, because there we go. Okay. I could zoom this out some. Does your graph look like my graph?
Yeah.
I mean, I can zoom it out and see what it looks like zoomed out. But
It doesn't change anything.
all I really need to know is where we cross the x-axis, yes?
Yeah.
And unless you zoom it out and all of a sudden you can see one that you couldn't see before. But keep in mind, our largest and smallest numbers are plus or minus 8, aren't they? So what's my only option? 2, yes? And was that in my list?
Yes.
Yes. So let's go back and let's try x equals 2. Okay. What was step 3 then? Synthetic division. Take whatever values, usually it's more than one, you found, and use synthetic division. 2's in my box. Next to my 2 is the, good, 1, negative 2, 5, and negative 10. Synthetic division,
Yes.
drop the 1, multiply. 2 times 1 is 2. Add, negative 2 plus 2, 0. Multiply, 2 times 0 is 0. 5 plus 0 is 5. Multiply, 2 times 5, 10. Negative 10 plus 10, 0. It works. Again, guys, I'm not expecting it not to work. It's not like I'm acting excited or surprised that it works. But I'm verifying that it works. Because if you don't get a remainder of 0, then know that you made a mistake somewhere along the line. Or you misread the graph or something. Now, with this in mind, okay, where are we at right now? What does a 0 of 2 represent when we start talking about factors later? Right, it's x minus a 0, so that represents a factor, x minus 2. Now, the whole reason we do synthetic division is not because I care about getting that remainder of 0. It's because I want those numbers right there. Okay? I'm basically dividing out the factor x minus 2, and I want to know what's left. What does 105 represent? Squared plus 5. Well, that looks a little bit easier to solve than yesterday's. A lot easier in my book. Okay, so that is the, right now, that's the other factor we have. Okay? Now, what was step 4 yesterday? It's finding your other zeros. Using whatever equation you just got, which we just got the, I mean, if you look at what we have right now officially, we have the x minus 2, yes, but the important one is the x squared plus 5. We already know we have x equals 2. That's not a shocker. Now, x squared plus 5. How do I solve that? Yeah. Do we have to use quadratic formula here? No. Enjoy it, right? Subtract the 5 over. So then I have x squared equals negative 5. Then what? Square root. Okay, we're taking the square root of negative 5 in an equation situation. Okay, in an equation situation, plus or minus.
I hate that.
What is the square root of 5? Square root of 5. What about the square root of that negative? I. So I'm going to say plus or minus I times the square root of 5.
Yeah.
Okay? Now, right there, those are my other two zeros. Okay? And I use the word zeros, or they actually asked us to find what? All complex roots. There's your roots. Okay? the 2, the positive I square roots of 5, and the negative I square roots of 5. Now, officially, and this is what you're going to have to do in homework on either one or both of them, I don't remember. They ask you for a factored form. First of all, before I forget, what's my A value?
1.
A is 1, so does it matter here? It does not.
Wouldn't there be D values?
There is, yeah.
Yeah.
A is just always the one in front of the lead. Okay, so one of our roots was x equals 2. What factor does that come from? X minus 2. Now, there's 2 ways we can write this. And one way, what was our other factor back here? We said we had x squared plus 5. And I think in this scenario, that's what they'd want because Savas does not appear to want i's in the factors. However, you have some in homework that they have square roots but not I, so I'm going to use this to demonstrate. X squared plus 5, what did it end up breaking down into? It broke into the zeros of positive I square root of 5 and negative I square root of 5. So you could see something that's like an x minus I square root of 5 and x plus I square root of 5. I just think what you will see in homework they won't happen to be imaginary. Okay, so like you might see an x minus 2, an x minus square root of 5, and an x plus square root of 5. So depending on the scenario, these are both good answers. Does that make sense?
Yeah.
Okay. I'm just trying to demonstrate because I want you to see something that I'm pretty sure you're going to see in homework. Okay, questions there?
Can I go home?
No. Okay, let's look at the back side. I don't know if we'll get this whole back. Well, I don't know. We might have time to get this whole back side done. We'll see. We're going to go a different route on the back side, whether that's good or bad for you. Okay. On the front side, we were talking about the rational root theorem. How can we use that whole P over Q business to find roots and get a start on problems? Okay. On the back, we're going to use something called the conjugate roots theorem. And this applies when a polynomial has imaginary or irrational roots. Okay, so if a polynomial has irrational roots or imaginary roots, then those roots occur in pairs. You've probably heard me say that before. When we talk imaginary roots, that's ones that have i's in them, right? You're never going to see just a single I. Okay, if there's a root of 5i, then there's going to be a root of negative 5i. Same thing, irrational roots. So think square roots here. Like, for instance, square root of 5, that's an irrational root. Those are going to occur in pairs. If you go back to what we just did, we had plus or minus I, the square root of 5. It occurred in pairs because it was imaginary. Okay, so important to know, irrational and imaginary roots occur in pairs. So, what this says, in terms of irrational, if a plus a square root is a root, or a plus square root of b, then so is a minus square root of b. In terms of imaginaries, if a plus bi is a root, then so is a minus bi. Sorry, it appears there's a little typo there, but you get the idea of what it's supposed to say. Okay, so either way, they occur in pairs. Now, where this is necessary, they sometimes like to be sly and say, okay, here's a root. And it might be one that needs to have a pair with it. So it might be one that needs to have a conjugate. And you guys do remember the word conjugate? I don't know if we've used that this year or not. The conjugate is where you just change the middle sign. Did you figure that out? Okay, so a plus bi, the conjugate is a minus bi. It's just changing that middle sign. A plus the square root of b, the conjugate is a minus square root of b. Okay, let's look at example A. what is a quadratic equation in standard form with rational coefficients that has a root of 5 plus 4i? Now, so they're giving me one root of 5 plus 4i. And they want me to write a quadratic equation. A quadratic equation is going to be x to the power of what? What's quadratic? That's x to the second? Yeah, 2. Second?
Listen, I think of quad and think whole.
Nope. X to the fourth in math is quartic. So, yeah. So quadratic equation, x to the second, which means there should be 2 roots. They only give me 1 root. What are they expecting you to know?
The other one's just with the sign flipped.
Yeah. If 5 plus 4i is a root, then what is the conjugate of 5 plus 4i? 5 minus 4i. Okay. These are conjugates. Okay. We're going to set this up in our factors and we're going to multiply. Ready to try it? Okay. Now, keep in mind, when we do these factors, if it's just a single digit factor, like 2, when we put it into the parentheses, into the factor, a 0 of 2 became x minus 2, right? It's always the opposite sign, so we're subtracting. So here, when we do this, for the first one, I'm going to write x minus, and what am I subtracting? I'm subtracting the 5 plus 4i. So notice how I wrote that to get us started. It's x minus the quantity 5 plus 4i, because we're going to have to distribute that minus sign. Then I'm going to do the same thing with the other 0. X minus, what's my other 0? The quantity 5 minus 4i. Okay, so it's no different than like on the front side. They gave us 2. What did I write it as? X minus 2. It's the same thing. Now, what if we distribute this negative here? So we're doing x minus the quantity 5 plus 4i. What is this? This is x. Distribute that minus. It's going to be minus 5, and it's going to be minus 4i. Do the same thing with the other one. It was x minus the quantity 5 minus 4i, so x minus the 5, and minus a negative 4i is going to be plus 4i. Okay, guys. Those are your 2 factors you need to multiply. Because they asked us for this in standard form, yes? So do I get to stop here? No, we're going to multiply. Yeah.
Couldn't we have just put them into the problem as is? Because it just x minus 5 plus 4i and x minus 5 minus 4i. Just essentially left it as is.
Because if you're looking at them flipped.
Yeah.
So I'm trying to reason in my head, and it's not happening on the spot. That's kind of a shortcut, and I'm trying to figure out, does that shortcut work 100% of the time? And I'm not willing to say I'm not willing to say yes to that question until I do a little bit of thinking and, experimenting. So I'm not going to agree to it. Okay. It's a shortcut. Is it a foolproof shortcut? That's where I'm not 100% sure yet. Is that a good enough answer on the spot?
Yeah.
So I want to say no. I want to say no, there's going to be an exception, but I could be wrong. So, okay. This isn't exactly FOIL, is it? Because it's more than 2 by 2. But it's kind of like FOIL. Everything in the first parenthesis multiplies with everything in the second parenthesis. So, you ready to multiply?
Mm-hmm.
I'm going to take x from the first parenthesis and multiply by each of the 3 terms in the second parenthesis. So, x times x squared. X times minus 5. minus 5x. And x times 4i. I like to write it as plus 4ix. Then I'm going to take my negative 5 in the first parenthesis and distribute it to the second parenthesis. Negative 5 times x minus 5x. Negative 5 times negative 5 plus 25. Negative 5 times 4i minus 20i. And then I'm going to take that negative 4i and I'm going to distribute it. Negative 4i times x. Negative 4ix. Negative 4i times negative 5. How about plus 20i?
Oh, yeah.
And negative 4i times positive 4i.
Negative 16 squared, which is just negative plus 16.
Okay, negative 16i squared is what I'm writing for the moment, but I do agree with where you're headed. Now, if we set up my problem right, and if we've done all of our multiplication right, beautiful things are going to happen. Your i's are all somehow going to disappear.
Yes.
The I terms will cancel. The IX terms will cancel. Yes, you still have an I squared term, but I squared we can turn into a regular number. I's are all gone. Okay? So, does it work it out? Plus 4ix cancels with minus 4ix. Minus 20i cancels with plus 20i. And I was just mentioning it, minus 16i squared, remember is, do we need a reminder?
16.
It's negative 16 times what is I squared? Negative 1. Negative 16 times negative 1 is a positive 16. We reviewed that lately. Do I need to review that? Okay. Now, final step, clean up. We're there, folks. There's usually just one x squared term. Carry it down. There's usually two x terms. Do you see them? Negative 5x and negative 5x is going to be negative 10x. And then you end up, in a way, adding two constants. Plus 25 and what became plus 16, which is my brain says plus 41. Okay? That's the example thing. We get some big bad problems here, folks. I'm not going to lie and I'm not going to try and hide it. Okay? They're not pretty. They take some work. Okay? You have to be very careful of your signs, your exponents, all of that. Questions on things we did on this one? And how this one went?
So this was an easy one.
Yeah, I didn't take up all the space. My next one, I'm going to take up all the space.
Cool.
My next two, I take up all the space. See, on my paper, there's a little gap here. I didn't quite use all the space. The next two, I had to write a little smaller, and I took up all the space. So, plan accordingly on these. You know, don't write huge if you want to make sure you fit all in nicely. Okay, let's look at B. What is a polynomial function Q? So they're just naming it Q. Of degree 4, that's nice. They're telling me 4, degree 4. With rational coefficients such that 2 minus the square root of 3 and 5i are roots.
I think it's a language. Can it phrase it in English?
Okay, yes it can. What is a polynomial function? So we're trying to write an equation again, a function like we did last time. Q, they're just calling it Q for whatever reason. I don't even know why I left that part in there, honestly. Should have taken it out. Degree 4. What's degree 4 tell me? Yeah. Highest exponent is going to be x to the 4th, and there's going to be how many sets of parentheses or roots?
4.
4, yes?
Yeah,
Okay.
I think.
with rational coefficients. That just means it's going to work out to have just normal number coefficients.
No I.
2, right, no i's in our final answer. 2 minus the square root of 3 and 5i are roots. How many roots did they give me? They gave me 2. They gave me 2 minus the square root of 3 and they gave me 5i. How many are there supposed to be?
4.
4. Why didn't they give me 2 more?
So you have to assume it's
That's where you plug in X.
Now, what do we know? If 2 minus the square root of 3 is a root,
Oh, the conjugate plus.
the conjugate, then 2 plus the square root of 3 is a root.
Oh, yeah. Nothing.
If 5i is a root, guesses?
Minus 5i.
Negative 5i. Now, 1, 2, 3, 4. Do we have 4 now?
See.
We do. Are we back to English now?
Yeah.
Okay.
Eventually.
Hey, we're going to do math here. Now, as we set these up, folks, it doesn't really matter what order you write your parentheses in, other than you need to put conjugates next to each other, because we're going to need to multiply conjugates first, because that's going to be the best way to get things to cancel out. So, I don't know, how fancy are we feeling? X minus, and the first one we were given is 2 minus the square root of 3, yes? Well, if you want to skip that step, how would this best be written? X minus 2, and then what?
Plus.
Plus the square root of 3. Okay. My next one is X minus the parentheses 2 plus the square root of 3. Well, if I'm going to take off that set of parentheses, it's what? X minus 2 and minus the square root of 3. What about 5i? X minus 5i? And what about negative 5i? Normally I would think X minus negative 5i, but what does that become? X plus 5i. Okay? If you're confident enough, you can just start with that second line I wrote. You don't have to do that first line. Now, as you get ready to multiply, folks, we have to do these in pairs, yes? And I cannot stress enough that you need to multiply conjugates. When we multiply conjugates, 2 beautiful things are going to happen. With the 5i's, all the i's are going to cancel out. With the ones with square roots, because they're conjugates, all my square roots are going to cancel out. Okay? And then we'll just be working with numbers. Okay, guys, now, we got to get to that point, though. I'm going to take this first x here and multiply it by everything in the second parenthesis here. The x, the minus 2, the minus square root of 3. You ready? X times x is?
X squared.
X squared. X times minus 2?
Minus 2x.
Minus 2x. X times minus square root of 3.
X square root of.
I probably would write minus x square root of 3. You could say minus square root of 3 times x, as long as the x is not under the parenthesis. Okay, so that was distributing x. Now I'm going to distribute negative 2. Negative 2 times x. Negative 2x. Negative 2 times negative 2. Plus 4. Negative 2 times negative square root of 3. Yep, plus 2 square root of 3. And now I'm going to distribute square root of 3. Square root of 3 times x plus x square root of 3. Square root of 3 times negative 2. Negative 2 square root of 3. Square root of 3 times negative square root of 3.
Negative.
Negative square root of 9 is how I'm going to write it for the moment, but yes, if you see it and your brain said, oh, no, that's not negative square root of 9, that's negative 3, I agree. That's where we're going to be headed. Now, because I don't want to move on and forget it, we'll clean this up in a moment, but we also need to FOIL the x minus 5i and the x plus 5i, right? It'll be nicer. So, x times x, x squared, x times 5i plus 5ix minus 5i times x minus 5ix minus 5i times plus 5i
Minus 25.
minus 25i squared. Okay, clean up. Now, like the i's earlier, these square roots, if you've done it right, the square root with x's, they'll cancel. Do we see some canceling? Minus x square root of 3 cancels with plus x square root of 3. Plus 2 square root of 3 cancels with minus 2 square root of 3. I see one other square root that I wrote, but what do we know about the square root of 9? It's 3, yes? So this is going to be a minus 3. Everything should clean up nicely now. So x squared should be a couple of x terms. Minus 2x and minus 2x is going to be minus 4x. And then constants. Plus 4 minus 3 is plus 1. Looks nicer now. Okay, don't forget about the other parenthesis over here. 5ix minus 5ix cancels. What's minus 25i squared? That becomes plus 25, yes? Because remember, I squared is negative 1. So negative 25 times negative 1. Okay, almost there, almost there. So what's that parenthesis become? X squared plus 25. Yes, you have to multiply one more time. Good news is my i's, my square roots, all the rough stuff is gone. Now, what kind of multiplying people are you? Do you always go first to second parenthesis, or like on this one, I would tend to take the x squared from the back and multiply it by each of the 3 things in the front, and the 25 from the back and each of the 3 things in the front, or no? Yeah, no, I'm seeing mixed emotions here.
There's less terms. What do you mean no? There's 2 terms to multiply by 3 versus the 3 you multiply by 2.
In the end, it's all the same no matter which way you do this.
Yeah, but like.
Okay. So either way, everything in the first parenthesis multiplies with everything in the second parenthesis. So if you just do this x squared out front, x squared times x squared is x to the 4th. And then if I go ahead and do x squared times 25, it's 25x squared. Now if I distribute negative 4x, negative 4x times x squared minus 4x to the 3rd minus 4x times 25 minus 100x. And distribute the 1. 1 times x squared is x squared. 1 times 25 is 25. Somehow or another, clean it up, yes?
There's so much.
I must have written smaller this time because I had that taking out like the whole thing.
It's not hard, it just takes forever.
Exactly, it's not hard. I'm not going to say it is.
That's why I'm complaining.
It's time consuming and it's tedious, right? You make one little small mistake
Messes it all.
and you can mess the whole thing up again, right? That's the annoying part. And I'm not going to disagree with you. Okay, so we had what? X to the fourth minus 4x cubed plus 26x squared minus 100x plus 25. Okay. I'm not going to get all of the last one multiplied out, but we're going to set it up. Fair enough? This last one, it says degree 4. If it's saying degree 4, how many factors should I have? 4. Okay. They give me a 0 of 3 minus 5i and negative 1 multiplicity of 2.
There's also 3 plus 5.
Okay. If they give me 3 minus 5i, we're smart cookies and we know there's going to be a 3 plus 5i. Now, negative 1 multiplicity of 2 says the negative 1 occurs
2 times.
2 times.
So there's
So you're going to have a negative 1 once and a negative 1 twice. Does that make sense?
So they wrote negative 1 twice. That is just,
Well, are you saying I shouldn't have?
yeah, because you already wrote it. Yeah, that makes more sense. Thank you.
There's going to be 4, one way or the other, okay?
It confused me.
Let's set up the parentheses. Again, I'm not going to have this multiplied out for you, but I can give you the final answer. But let's set up the parentheses. That's what I'm concerned about. I'm going to start with the 3 minus 5i, which I'm going to write as x minus the quantity, so parentheses, 3 minus 5i. If I take off those inside parentheses, this is really what? X minus 3 plus 5i. Then we also have x minus the quantity, 3 plus 5i. If I take off those inside parentheses, x minus 3 and minus 5i.
So far, my question still stands. As
What about the negative 1? Officially, it's x minus negative 1, which is what? X plus 1. And then what do we also have? Another x plus 1.
can we write that as x plus 1 squared?
You should not, because we have to FOIL this out.
Alright.
You could write as x plus 1 squared, but then you are tending towards a foiling issue.
To forget about it.
Yep. Okay, guys. From there, you guys know what I'm going to do, yes? We're going to multiply the first two, and then we're going to multiply those two. We're going to get those answers and clean them up, and then we're going to go for a final answer. I'm going to perform some magic here, and I'm going to tell you the answer is x to the fourth minus 4x cubed plus 23x squared plus 62x plus 34. And that's magic, because I just did that all in my head as I'm holding this piece of paper up in front of me and copying it down for my notes.
How'd you do it?
Magic. Okay, sense the sarcasm, right? Okay, now, if you want a project to do, can you work that out and see if you can get the right answer?
Oh yeah, definitely.
You can. Some of you probably will. Now, is there any homework due Monday? Do you need to do anything over the weekend? No. Monday will be a work day. I'm going to tell you, there are some tough problems in 3-6, okay? So, but Monday will be a work day.